Madhu, shall we start?
Hello, sir. Hello.
Can we start?
Yes, sir. Abhirami is here.
Okay.
She will be anchoring.
Hello.
Okay, Abhirami, go ahead.
Okay, sir. Thank you, sir. Am I audible?
Yeah, you're audible.
Okay. A very good evening to one and all. Today's session reminds me of a quote said by Karl Marx. Nothing can have value without being an object of utility. So let me welcome you all to the third chapter of webinar series with experts from KCB LCD, conducted by PES Kerala chapter on future power challenges, how the public sector utilities are gearing up. For a good beginning, I would like to welcome Dr. Shobha Manekal ma'am, Vice Chairperson, IEEE, to the introductory speech.
So, good evening all, and thank you, Aishwarya, for this opportunity of making some introductory remarks in connection with the webinar series conducted by Kerala State Electricity Board upon the request from PES IEEE Kerala chapter. So today we are having Engineer Laiju MS, Assistant Executive Engineer, Kerala State Electricity Board, and he seems to be associated with renewable energy and energy savings, and he will be doing
Teacher, sound.
Hello.
Teacher, sound
Yeah, I think some net issue is there. Hello, am I audible now?
No, ma'am. Ma'am, മൈക്രോഫോണിലാണോ സംസാരിക്കുന്നത്? ഫോണിന്റെ മൈക്കിലാണോ അതോ അല്ലാതെ ഹെഡ്സെറ്റിലാണോ?
ആണ് ഫോണാണ്.
ഫോൺ ഒന്ന് കുറച്ചുകൂടെ അടുത്ത് പിടിക്കാവോ?
വളരെ അടുത്താണ് പിടിച്ചിരിക്കുന്നത്.
ഓക്കെ മാം. ഓക്കെ.
Okay, go ahead, ma'am.
Oh, okay. Audible ആണോ? ഞാൻ മാറണോ? സ്വിച്ച് ഓവർ ചെയ്യണോ? I think anyway, I'll continue because more important is the presentation. Okay.
Yeah, it's audible too. Yeah, it's audible, but a little bit sound. If you could make louder, that is greater, ma'am.
Yeah. I'll make it little more louder.
Okay.
Anyhow, as we know, the significance of this topic is very high, especially because not only it is not a local concept or a nation-wise concept. It is actually a global phenomena, and we are going to tap solar energy as far as possible because mankind has understood that the only hello. Yeah, I think I'll switch over. 1 minute.
Can we start?
Oh. Oh, am I audible?
Yes, ma'am, you're audible.
Now we can hear me.
Yes, ma'am, yes, we can.
Yeah, okay. Now, yes, I'm just giving some introduction on the webinar series, which is being conducted by IEEE PES Kerala chapter in association with Kerala State Electricity Board. So this is actually this impact on global impact due to the excessive use of fossil fuels has been realized in 1920 when Thomas Edison has given a remark that we are like tenant farmers chopping down the furnace round our house for fuel when we should be using nature's inexhaustible sources of energy, sun, wind, and tide. This is the remark we have given. And today's session, we are going to hear how the public sector utilities are gearing up. Basically, Kerala State Electricity Board has come up with a lot of initiative so as to explore and optimally develop renewable energy resources in the state so as to meet the electricity demand in future and save electrical energy through energy efficient measures and demand side management. We have heard about Urja Kerala mission, Duty, filament free Kerala, EV charging stations, rooftop, and now again floating solar has also come up. Basically, solar fuels floating on top of water, it has become a new standard for solar energy production, and it is yet meeting a lot of technological challenges which are to be mastered. And the progress and realization of these projects, it is possible only because of the expertise, dedication, and far-sighted thinking of a group of power engineers allied with KSEB. And today we have such an eminent person with years of real experience in this field, who is going to share his views and his experience on dam top and floating solar projects of KSEB with the esteemed gathering. So on my personal behalf and on behalf of IEEE PES Kerala, I would welcome and of course Engineer Teju, and I would request Ajit Gobi to take over and introduce the speaker officially to the gathering. Thank you all.
Thank you, ma'am, for those warm words. Now I invite Engineer Ajit Gopi, sir, Vice Chairperson, IEEE PES Kerala chapter, for giving introduction of speaker.
Good evening, all. So, thank you, ma'am, for the introductory remarks in this session. IEEE PES Kerala chapter is organizing this webinar series. From the experts from KCB Limited. We had 2 sessions before this. And this is the 3rd session actually happening. And we have Laiju MS with us on board for delivering the talk. I will take this opportunity to introduce Laiju MS. Laiju MS is actually working with the Renewable Energy and Energy Savings Division, KCB Limited, REES. We always visit there as renewable energy people from ANAT. So, in that terms, he is also our colleague. And telling about Laiju MS, he's so passionate engineer in renewable energy. I know him for the last several years on various occasions. Engineer Laiju MS did his MTech in power system. He is actually a chartered engineer of MNRE, Ministry of New and Renewable Energy has introduced a chartered engineership program. So he is a chartered engineer of MNRE. And before joining KCB, he has got some academic experience as well. He was with 4 years he was in IHRD Engineering College, Adur, and 1 year in IHRD Engineering College, Chenganur. He already completed 20 years of his experience in KCB Limited. The more than above, Engineer Laiju MS is very familiar to me in academic circles also, because he always. Yeah, good evening. Can you? I guess, Laiju sir, can you hear me what I am speaking? I'm just asking. Could you hear me? Yes, some audio issue with Laiju sir, but that. Okay, could you hear me, sir? Could you hear what I'm? Can you hear me? Hello, sir. So kindly, can you hear me? So there will be some audio issues that we will address, because we will be presenting the screen will be presented by the team, a student team, while Laiju sir will be speaking during the occasion. That we will ask him to initiate the discussion. Yeah, I know there is some issue. So it's great that we have Laiju MS, experienced engineer from KCB.
Sound not receiving.
Madhu, we will arrange it. We will arrange it, sir.
Just go to the sound. Just the sound.
Okay. Can you hear now? Can you hear now, sir? Can you hear me?
Hello, sir.
Yes, I'm speaking, sir.
Sound has gone.
Madhu, hello, Madhu.
Yes, sir.
Can you just unmute him so that we will after this introduction we will let him.
Yes, sir.
Yeah.
Sir, please continue.
Yeah. Thank you. So engineer Laiju sir, actually he's so familiar with the academic sessions, because whenever there is a program on the updation of renewable energy equipments, if it is happening all around the globe, he will be there. I know that he has visited a lot of international seminars and gatherings of renewable energy people around the globe. So he's so passionate in updating his knowledge on renewable energy equipments and systems. So I take this opportunity to welcome Laiju MS. He's working under the Renewable Energy and Savings Department under KCB Limited. We are happy to welcome sir. Anyway, we will make the audio available. Thanks for the small technical errors, because his laptop having small issues. He'll be presenting shortly. Thanks again. Over to you, sir.
Hello. Thank you, sir, for the clear introduction. Now it's time to start our sessions. For that, I humbly request the most eminent engineer Laiju MS sir, Assistant Executive Engineer, Empanel Chartered Engineer,
No, I
Ministry
can't
of New
hear
and
any
Renewable
sound.
Energy, Government of India.
Hello.
Hello,
Can you hear
sir.
me?
Can you hear us? We can hear you, sir. So you can start your session, sir.
Can you hear me?
Yes, sir. You are audible.
I can't hear.
Laiju sir, you are audible. You start your session. Please start your session. You are audible.
Okay.
Though you couldn't hear, you start your session, because there is some issue with your audio video devices. So can you please start? We will scroll your presentation.
Good evening, all. Good evening to all. Here we can discuss of KCBL. Am I audible?
You are audible, sir. You are audible,
Yes,
but
audible.
you are audible, but you couldn't hear.
I
Unfortunately,
can't
sorry.
hear the sound. That is why I am asking whether I am audible to all.
Yes, sir. Very clear.
Okay, okay. So before going into the frame top of the different types of projects of KCBL, why we are going for these projects, why we are going for the solar or renewable energy. That is the first thing I have to say. So the renewable energy and its applications we can discuss. So for the present scenario, due to the shortage of fossil fuels like normal, thermal and other generators, and the shortage of the thermal fuels and other fossil fuels. So in the coming generation, we plan to generate electricity from such sources which has plenty of availability in nature. So what are the sources from which we can generate electricity without affecting the nature or getting the generation by a clean and green environmental condition? Without carbon emission, how we can go for such projects which give an idea or which presents energy. That is why we are going to the renewable energy sector. From what type of renewables we are planning and we are taking into account for this purpose? So the first of all, I have to say that the plenty of availability is from the sunlight, wind, biomass, etc., out of which we are selecting the solar for the time being. So what type of solar energy is what type of conversion principle which we can adopt in our present conditions? So depending on the climate conditions, whether we can go for solar photovoltaic or from solar to solar energy to electricity or heat to electricity from sun. So first of all, we can discuss whether it is plenty. So the second thing is, what is the material by which we can convert the solar power into the electricity? So we are going for the solar panels. So the thing is, where we have to place these panels, how much area we require for proposing a large plants similar to the plants of the hydro, etc., which are a large power plants. But in Kerala, we could generate only less than 20% of the demand, out of which it is met from the major generating stations like Idiki, Mumbai, etc. So we have to think of generating more power from the available resources. But the hurdles which occur is the scarcity of land where we can build such solar project or place the transducers in such an area to build up more and more or large projects like megawatt scale. So we are thinking of an alternative solution of unutilized areas of our own place, whether it is in the dam, near to dam, whether it is in the canal portion, whether it is in the canal area or in the rooftop. So KCBL plans to develop such renewable energy from solar in such a way that the places which is unutilized can be used for that purpose. So for selecting a project which is unique and first in India, we are taking a location in Wayanad district. So first of all, we can go for what type of project is that? There is we are planning a grid-tied a project on the roadway of a dam. A dam is primarily in the Wayanad district and the area known as Padinjaratara or Banasura. What type of dam is that? It is an earth dam. In that roadway of the dam, we planned the first project. So the project from the area where we can select the project for making a generation of a project such that the project, I mean, for a scale of 1 megawatt, initial planning was done. So in the road area, we select how much area we can select. So first we are thinking of the length of the road, that is more than half a kilometer from the part, from the initial level to the end. So around 637 or 640, more than 500 meters, out of which how much area we can utilize. What will be the span or of the roadway? So initially the span is around 6.4 meters, but the span is increases from the 0 meter to 637 or more than 500 meters. So we are thinking of how much area we can select, and depending on the fund availability, we select some area of about 270 meters from the initial side of the initial portion of the roadway, and we planned to construct a structure in such a way that passing of large vehicle can also be accommodated, and our project should be withstand for 25 more years. So the panel and its module mounting structure should be selected. So what type of panel is available at that time? So we are taking that we selected a panel that is of diameter 250 from PV Power Tech, the manufacturers, and that panel. Hello, sir. Yeah, I can see the screen. Yeah. Current screen I am seeing. The front portion of the project. Okay. No. I will say to him that he has to pass. Okay. He can move the second slide. Okay. He can. I will tell you. Okay, direction will be given. Okay, sir. Please move the next slide. Please pass the next slide. So here you can see the major components of that project. That is the size. We are initially thinking of 1 megawatt, but depending on the fund availability, we split that into 2 phases. And in first phase, we plan to generate for a capacity of 400 kilowatt. So we are using PV Power Tech company's PV module, which has a capacity what we call for 250, and such 1760 panels are selected because we are getting we required to get a capacity of 400, but we select 1760 panels, which is 10% more of the required capacity. So around 440 kilowatt panels we have selected. That is 1760 panels, and the model is ECO 250. So normally the dimension we can treat as what area it is requiring. So 1.6 by 0.989 by 35 mm. Roughly we can say that 1.6 by 1. So 1.6 m square area required to place one panel. The constraints which are arising is the structure will be 3.4 meter or more height. It should withstand wind stress of 150 km per hour. Plus stability. Being an earth dam, the roadway area we can't drill or we can pile more. To secure the earth dam and fix the module mounting structure in such a way that it should not affect the dam stability, but it should be stable and withstand the MMS on which or over which our panel should be placed. So we are designing such an MMS such that it should withstand the panel. So normally each panel weighs around 25 kilograms. So around 1760 panels, it will be large structure. That structure should withstand, and that should withstand for a period of 25 years lifespan of the panel. So what we are generating is a DC power. So the second stage of this is we require a component which should convert the DC into AC form. So we can say that we can use an inverter. So in this project, before going into lead of the project, I will say that we have selected an inverter which should be placed on the outside, not in the control room, but along the structure of the panel module mounting. So just on the poles of the module mounting structure, we are placing such inverter, which is known as string. So what company the string inverter supply? A Delta make 50 kW capacity inverter, kW per kVA capacity inverter has been placed. So how much inverters are required for obtaining the 400 kW? I had already said that we had used the panels such that we can produce a maximum of 440 kW. So how much inverters required to meet that condition? So we are selecting 50 kW and the model is RPI M50A, from which the capacity is 50 kW. So total around 440 or 450 inverters has been connected. So 9 such inverters are placed to make 440 more capacity kW. So whether the inverter, normal inverter, could convert the DC into AC? No. We are using an inverter which should address the square wave which is generated, which is converted from this inverter, make it shape, and shaping is required to make the AC sinusoidal form. So we can say that it is not only said as the inverter, but also it can be treated as power conditioning unit. So now onwards, I would say that from the panel, after circuitry connections, it will move to the inverter. So inverter, which is now onwards, we can say as power conditioning unit, which shapes the power AC in sinusoidal form. And the power which is generated is 433 volt. So 433 three-phase volt, that should be converted into 11 kV depending on the power evacuation requirement. So as per regulation, we can say that up to 100 kilowatt, we can connect it in LT side, but above that, it will be on ST. That is power evacuation required in 11 kV. So the next step is we have to step up the 433 into 11 kV. We are using a 630 kVA transformer, 11 bar 440, that is 433 bar 11 kV transformer is used to convert the stepping up process for evacuation. So in the dam top or roadway, or the project can be named as canopy project, we should achieve the capacity by seeing that on a screen if we require. So what are the components from which we got the idea that this project is generating such thing? So in between we require the equipments. We should have the control through the complete project. So a SCADA which is used, supervisory control and data acquisition system, which requires so many data. So we need what will be the radiation, what will be the temperature, what are the panels, what type of panel is used, what type of inverter is connected, whether the strings used to connect the panels and how to join the panels. What is the component which is used to join the panel to the inverter? So such queries arises. We can have a panels in series or panels in parallel. How we can select that depending on the generated voltage from each panel, generated in the current flowing through panels. All such data will be given from the manufacturer's data sheet, having electrical parameter and physical or mechanical parameters, the dimension, weight, etc. is the physical and electrical components, the capacity of the panel, its voltage, and the current passing through. These are the major data by which we can design the project. So in a string, how much current can be allowed to pass? What type of cable can be used? How much will be the capacity? These are all primary things. So here we had taken such liberty in such a way that we should add the components to fire up and complete the project. So what is the component which is used to interconnect the panels and join the panels? There should be an array junction box, or string should be combined in a string combiner box. In some cases, we have a string monitoring system also. So that all components can be placed in the I sections or the poles of the module mounting structure. So in every electrical circuitry, before completing the design, we have to check the safety aspects also, whether it is properly working, the over voltage, undercurrent, over frequency, open circuit, short circuit, every case should be addressed. So all the conditions should be addressed. Then the structure should be properly being the structure. So what type of structure is used? It should withstand 25 years. So we are using an MMS, which should be termed as hot-tipped galvanized. The mild steel, we should be hot-tipped galvanized. And the thickness of the tubes which are used is also mentioned depending on the size and depending on the structure height, etc. So normally 2.9 mm, 3.5, etc. is used, or 2 mm tubes will be used for this MMF structure. I am not going into details. Here, the MMF structure should withstand such weight of panels over. The second thing is CAD should give the details in our computer system for RS485 or etc. should be connected in such a way that we can address the radiation, the temperature, generation from each inverter, summing up, etc. All should give in the control room. So in the control room, we have such arrangements with the PC. We can have a look at how to operate. We can switch on off remotely as well as from any place. That is the main advantage of this SCADA system. During the discharging period, we from Trivandrum, we control all the operations of the project, 400 kilowatt grid-tied solar project from our headquarters. That is Patam. Check. Putting on inverter 1, inverter 2, etc. Putting on full system, switching off all, checking the voltages, checking the parameters, and the units generated. Here, the major advantage of that area is the temperature. So, due to such temperature, we can actually we have planned to get an annual generation of 0.5 MU, but we go to the first year. That is after commissioning on 16. I think 2016, 4 years back. Still, the generation is more than 5 lakh units. In the first year, we got around 8.2 lakhs. Now also we are getting 7.9, 8 lakh units. So it is a success. So the first time in the world, we are done a project, the dam top. So this is the first project in the world. So 400 kilowatt dam top project is the first in the world. So our aim is to get more power in the grid with the available area of the reservoir area we are used. The second thing, coming into water bodies. So actually, these are unutilized. So as a pilot, next slide please. Next slide. Next slide. Next slide. This is for the pilot project. Previous slide. Previous slide, please. Previous slide. Here, we have planned a floating solar project. Actually, it is the idea of our teacher or professor, RBG Menon sir, who has the key to give the ideas to such students, and we promote the ideas through a startup during 2016. We had given such work to two engineering college students, Ajay and Sudhin of Fine Engineering College, who had done an excellent job. Self-designed float, we should withstand the panel and the entire structure. So we utilized an innovation fund which is received from the government around 15 lakhs. Initially, we got lot of hurdles to be addressed to make the float to anchor in and around the areas of the ground, and the earthing and the cable laying through the water body to the ground area, and for the metering and other purposes, and evacuating power to the system or grid. So we give all support to them, and they completed the project in short span, and their daily generation initially is around 43.5 units, and the float is a large one, 10.5 by 9 by 1 meter. It's a hollow float structure used by the ferrocement, and they should anchor in 4 locations. Actually 80 meter long, normal nylon rope is used with a spring mechanism. Why we need such mechanism means here the water body level will be rising. The difference level rised around 20 meters from 3 to 23 or 25 meters, etc. So we should address that. So the nylon rope and the spring system should be placed in such a way that it should move around, anchored, and it should be float over. So initially we got a lot of hurdles in anchoring, and during 2018 flood also, the spring has some problem. We have replaced, but 2019 flood it is not affected. So on the success of the commissioned project, you can go for the next slide to see the project. So you can see that 10 kilowatt floating plant. After commissioning time, we have to incur around 20 lakhs. The 15 from the innovation fund given by the government, and the balance 5 lakhs is utilized from the ports fund. So you can see that the flow with that dimension, it has and addressing all things, and power is evacuated by using a cable to the ground, and we are giving it to the grid. Here the inverter is from ABB, string inverter 10 kW. It has got 2 or 3 times the problems, and the ABB company addressed that problems timely, so that we couldn't we can continue generation from the 10 kW project. So from the success, we thought thinking of whether we can go for a large scale. So we planned another 1 megawatt as a first scale. First phase we take only 500 kilowatt as another innovation project that is also funded by Government of Kerala, and they allotted with a fund of 7 crores to begin with. So here the floating, we can move to the next slide, please. Next slide, please. Next slide. Next arm. Here you can see that here we can select how we can select the plant capacity, how we can select the floats which are capable to float over the water body, and how it can be materialized the 500 kW scale project. So based on the initial pilot project, we have to design the float in such a way that it should address the environmental variations, that is water level variations, temperature variations, wind stress variations also. And the water body should float without dip in the water body. So we thinking how much area is required depending on the modules dimension, depending on the structure, how much floats require is also depending on the capacity. So capacity once fixed for the first phase 500 kilowatt, and we get the area around 1.2 to 2.5 acres, and how much area required for each plot, and how much plot is required to complete 500 kW project. So what type of panels and inverters is used, whether a substation and power evacuation setup is required, whether it can be placed on a float, control room is on float, etc. So after detailed discussions and deliberations, we concluded in such a way that a single plot, which is initially constructed and can be treated as a mother plot, mother plot, and its dimension should be more, because over the mother plot we have to plan the successive plots. The other plots they should float to the water body. So that is the tedious job. Initially we get a lot of wordings, how to stabilize over the water body, how to anchor the mother plot on the water body. The hurdles is initially it has dipped, but due to some other mechanisms we could achieve to retrieve from the water body and place stable on the water body. So after that we make 17 more floats. So thinking of how much float is now about 17 plus 1, 18. One is the mother float, other is 17 floats. So we keep the mother float as such and thinking to make structures over the other floats. Whether each float is caliber to withstand or hold the structures and the panel widths. So I already told that the panel which will be around 250 260 watt peak with a weight of 20 kg with a dimension of around 1.6 by 1 or 1.8 or 2 m square area. So that's what the area is required. So we have to design how to contour the panels or panel laying, how to make the panels laid on each floor, and how much panels can be laid, how the electrical wiring can be done, how electrical sizing of inverters can be made. During the DPR, detailed project report time, we are thinking of only 2 inverters. And we shall plan that we should use central inverter. Central inverter means an inverter which should be housed in a room. That room is the SCADA room or the control room. So initially 2 numbers of 300 kilowatt inverters, central inverters are selected. But depending on the site conditions, we change. Why we are going for such large inverters? Instead of that, we are thinking of whether it is suited. So we have to design, we have 17 floats and we require to achieve a capacity of 500 more. So 17 means the string inverter sizing is around 30 range. So we got Delta make inverters. I mean ABB make 33 kW inverters. We selected 17 numbers to get 500 more capacity, 500 kW more capacity to the project. So first is selection of panel is over. How much panel can be selected in a plot? That should be coming later. So inverter selection means a 30 more kW inverter. So panel should be sized in such that you will get achieve nearby 30. So 260 into how much panels and how much rows we have to fix the plots. So number of metrics we have selected 18 by 6, 19 by 6, and finally we arrive at a design of 23 by 5, that is 150 into 0.26, that is around 29.9 and 30 kW. So how much will be the capacity of capacity generating from each float? That is around 30 kW. Each inverter, the company says that we can load more. So assured capacity will be 30 from each panel and 17 each float coming. Some of the or integrating that 17, we will get more than 500 kilowatt. So the second tedious process is how to convert that, how to move the generated power into our grid. We are using such cables which converts, which moves, which will be taken from the float and wiring up each and every float, summing up. It will be moved to the control room. So you are thinking control room will be on the ground phase. No, control room, the unitized substation, etc., is on the mother float. So how many number of floats are there? The floats are comes to 17 plus 1, 18. So 18 the float, control room, transformer, and other accessories. So why we require transformer? Since the power is 500 kilowatt, we have to address it into 11 kV. So 433 or 415 volt, which is generated, which is available at the inverter output point, should be step up to 11 kV to connect it with the grid. So grid interaction, grid interconnection, we require that the LT should be step up to ST level or 11 kV level, and based on regulation also stepping up that voltage. So please move to next slide. Please move to the next slide. You can see the major components in a sequential order I had shown. You can see first box covering up solar PV modules. Second, the string inverter portion. Third, module support system. Fourth, the floating and the moving bar anchoring system, grid supporting, SCADA, cables, transformers, etc. So thinking of the total circuitry coming, and the risk involved in is how to take the cables, how to anchor the floats. So these are the main hurdles during the execution stage of the project. So if after more and more trial and other things, since being an innovation project, more and more trial, we could achieve that we can properly anchor the floats to the ground, and we can properly earth using special grade cables, earthing using special grade cables. Special grade cables are also used for the power evacuation, earthing, etc., in such a way that the safety aspect in the floating project is also addressed. Here also, due to the low temperature around 20-25 degrees, and the water body, the panel structure all in floating in water level, the temperature will be low, so the generation will be more. Here we get a study, and in the study report we can say that around 6.5 units generated per kilowatt. Such a nice generation. It has been more than the planned capacity of 6.25 lakh units in the while the preparation of the project report. So during the project report preparation time, we found that we will get around 6.25 million units of power can be generated from this 500 kilowatt grid-tied floating project. So our mission and our aim, our target, unutilized areas like the dam area, the water body areas, that is floating, can be achieved, has achieved. So based the other slides, you can see that the different stages. The next slide, please. Next slide. Next slide, please. Next slide, please. You can see, next slide, Sir, next slide. You can see the construction type floating structures. You can move. You can move the slides. The mooring and anchoring system you can see. Next, the module mounting structure with the modules. Next slide, please. You can see the cable management system. Next slide. The floats. Next slide. In-depth. Next slide. In-depth structure of the float. Next slide, please. Next slide. Next slide. You can see the panel completely mounted, and you can see the control room also, but I can't get the full picture of the control room. A aerial view, you can see there is a control room is also one of the floats. So properly anchored floats you can see. This is the entire view of our 500 kilowatt solar project. It has not affected the aesthetic view of the area. You all know that the Banasur Sagar area is a tourist place where more tourists are coming. So our hurdle, without affecting the aesthetic place, aesthetic scenes or the beauty, we have created such projects. One is on the canopy and another one is on the float. The next slide, please. And another view. Next slide. So based on the success, we are planning to install, and we are thinking of whether we can go for some more large projects in these areas, since we have a number of large dam and areas available in our project, large project areas, Idiki, etc. And different levels of the quarry areas where unutilized land is there or the float area is there, utilized for scaling up big projects. So we are initially joined with the Solar Energy Corporation of India and surveyed for around 100 megawatts floating solar project in the Banasura Sagar area, which is covered up with the 21 more islands. And the survey is almost in the final stage. And SECI and KCB jointly doing the work. And SECI will be, I think SECI, the final shape of the project is yet to come. The SECI will complete the work and sell the power to KCB, I think. The PPA and other things, tendering and execution is still in the pipeline. So we can say that the other floating solar projects in pipeline, the first we have selected is the indications are in the different way. Banasura Sagar 100 megawatt project we are tying up with SECI. Another 50 megawatt project in the West Kannada area, which is with the NHPC. And Idiki Reservoir 2 areas. Cherdoni area we with 25 megawatt and Anjuruli 100 megawatt we are tying up with NDTs. So around 275 megawatt floating solar projects in the pipeline we should materialize. So the large volume of or megawatt scale projects are coming, and it should be completed within 1 or 2 years, I think. So each project completion requires the major transmission infrastructure augmentation. So that process is in parallelly going. So we can thinking of such projects, but we have to face some challenges also. So in that areas, we should more cautious while interfacing such RE resources to the grid. And if any characteristical change or the climate changes, the baseload generation we thinking of will be less. So in some areas, the integration, we should wait for some time because the evacuation constraint should be passing through the forest and other areas. That should be the transmission and other lines construction. The hurdles will be occurring in forest and other. If any area having more and more vegetation, then it will be very time-consuming process to complete the construction work over there. So, next slide, please. Next slide, please. Next one. Next one. Next one. So, we are using the irradiation in such a way that we should make power connected to grid in large scale in future. Thank you.
Thank you, sir. The session was really interesting and informative, and it was great to hear about the projects in detail.
Questions, please.
Yeah, now it's time to welcome some queries. So I would like to invite Ajit Gopi sir to address the queries if there is any.
Hello, hello all. Thank you, Layu sir. Can you hear me? So I think initially itself there was an issue.
I can't hear.
Yeah. Okay, fine, sir. No problem. What I suggest is
Sir.
you can hear me. Okay,
Hello?
very good. Sir. Can you hear me, sir? Can you hear me? Yeah.
Any questions, please?
Yeah, we can. What we would like to suggest is that attendees, please type your questions, queries into the chat box, and the team will be collecting it, and we will be communicating with Laiju sir and get his response.
Hello.
This issue was there actually because of his.
Hello, sir.
There is some issue with his laptop, and
the audio is breaking, sir.
Yeah, audio. There is
you can
audio with
in the chat box.
Exactly. So we will collect the questions in the chat box and communicate to him. I will call him directly, and I will just ask him to collect the questions from the chat box, and he will be answering. So I kindly request all the participants to put your questions in the chat box so that it is easier to collect. I will call him directly. Thank you for your cooperation because of this technical issue. I will call him and let him know. Thank you.
Hello.
So, dear attendees, can you make sure that you are putting the chat with everyone in the meeting?
Hello.
So that, yes, sir, you are audible. Yes, sir, you are audible.
Hello.
Yes, sir, you are audible. The questions are in the chat box. I think Register is not able to hear us.
Madhu, I am afraid that he couldn't speak. He couldn't hear us. So
exactly.
Can you just look at? Can you just look at the chat box? Can you just look at the chat box? Yeah. You can just follow the chat box and answer the question, sir.
Okay. Can you hear?
Yeah, yes, we can hear.
Sir,
can you follow the
Go ahead, thanks for the questions. The first question is, can you please suggest earthing arrangement for floating solar projects? And how do we ensure 25 years life for anchoring and hardware having system on water? Is there any difference in output efficiency of floating solar compared to ground mounted system? What is the total generation planned by KCB in solar? So I will, should we have used submergible cables? So I will start from the last. Should we have to use submergible cables which are used for the submarines or the ships. But here we are using the special grade cables, which is capable to hold or handle such capacity, current flow, and protection. And the total generation, what is the total capacity planned by the KCB in solar is our Saura project announced by the government of Kerala is 1000 megawatt scale. First phase 500. In that 201 in reverse bidding, etc. 46.5 megawatt is already work awarded, and second phase is in progress. So our target will be 2022 more than 500. That is nearing 1000, which is the Urja Mission project of government of Kerala, and KCB is planned in line with the directions of the government of Kerala. So, is there any difference of output efficiency of float solar PV system compared to ground mounted system? Sir, it is a nice question. We can see that in the ground mounted area, the surrounding temperature variations will also, every temperature variation will also make dip in panel generation. But when it is in the float, due to the environmental condition and the temperature, since the temperature is much less compared to the other ground mounted areas, normally the generation will be high. And the efficiency of each stage compared to ground mounted floating system will have more due to the conditions where it has been placed. How to ensure the 25 years lifespan for anchoring and hardware having the system on water? You can see that for the two floods during 2018 and 2019, our project has not having any damage occurred. Here we had designed such that it should withstand for long years. Of course, you say that whether it will be having a life period of 25 years, but being the innovative project and the materials which we are selected and used, and the material manufacturers assured us that it has the caliber to make whole the lifespan completely. If it should not happen, then we have to think to renovate structures in such that it should utilize for more of the lifespan of 25 years. Here, sir, another question, cost comparison based on land and solar power plants and floating. So the land area, if you are planning the cost of the land, if it is own project, the cost is immaterial. But the materials which we require will be more compared to floating. Since floating project, we should complete around 7 to 9 crores. Here in this project, we have to utilize 9.25 crores. Out of the 9.25 crores, government of Kerala has given us 7 crores. The balance 2.25 crores incurred by the board. Here, the project for 500 kilowatt, but normally the ground mounted we require around 4.3 crores at the present benchmark rate of the Ministry of New and Renewable Energy. 2021 rate is 4.34 crores. Now it is slashing down to 3.624. The latest statistics says that the project cost is slashing down due to the dip in the prices of all major components utilized for the project. Here the safety challenges. So initially the safety challenges in the floating model and how is it addressed, and also there exist leisure boat services in dams, and how does it get affected with the implementation of floating model solar power plants. Here consider the case of Banasura Sagar. The leisure boat or the tourist boat services is not passing through the float project area, but it is in other areas which is we are giving for the hydel tourism package. The safety challenges, the earthing and other safety issues addressed, and in the control room, all safety regarding equipments and other things which is essential is placed, and a boat is also provided for the project, and the operators are available, so we can address any safety challenges. Here, since the another nice question, that is, since solar is intermittent and generation, how we can meet demands as we cannot schedule it accurately? Your point is okay. Since the prediction, here we are planning for a 365 days, but how many solar days or sunny days available with, depending on the climate conditions? We think that we can get 8 to 10 months maximum in Kerala's environmental conditions or Kerala's climate conditions. I mean climate conditions. So 240 to 300 days maximum we will get. So during our project compilation or project scheduling time, we found that we are consider only that period and analyze how much generation is possible. That is how we arrived at the conclusion that we will get around a minimum or in between a 6.25 lakh unit or 0.625 billion units will be generated from this project. I will be putting this presentation on YouTube. You can ask for Ajit Gopi sir to ask him whether it is recorded or not. That I don't know. If it is recorded, I request whether it is put it on the IEEE site or not. You said the cables are selected based on load current, but when the cables are used in water, should the cables, submergible cables, or should special protection for cables? Earthing of solar panels equipment should be done to waterbed or to shore. It is also a good question, sir. We are selected a special grade cables as the substation and all things we are provided on the float, and the power evacuation stages and the 11 kV grid and the earthing provided shall reduce the step and touch potential to a safer value so as to avoid any possible hazard to the operating personnel in the float or coming near to the float. Presently, there is no standards which is followed for the designing of the proper earthing with the floating solar plant. In the 11 kV base substation or the unitary substation is in the float. There is a risk current of a fault current which is allowed to flow through the reservoir water, but it is addressed as per the IEEE 800051. The earthing method is followed. Similar to the ship takes short stay at the shore or the port, and it take power supply from the shore. So we have followed the similar earthing methods, and the mechanical structures all directly connected to the shore area by using the redundant insulated cable. I think where all the questions has been addressed, why polycrystalline panels were selected instead of monocrystalline. Sir, at the time of our project planning, the monocrystalline has not become popular, and the available at that time to 16 period, it is we are easily getting the multicrystalline, that means polycrystalline, and the manufacturers are coming into the Kerala zone. So at that time, we will get panels from PowerTech, Radiant Solar, Wari, Vikram Solar, etc. Now, lot more companies coming into picture. In our projects, the major projects, we are utilizing the panels from Thompson, Wari, and the Adani's Mudra Solar, etc. So, new trend and new innovative models came in picture and we are selected. It is not because at that time we are not getting the proper mono crystalline panels. That is why we selected the polycrystalline panel there. One is PV PowerTech and other one is Radiant. PV PowerTech panels used in the dam top and the Radiant panels used in the floating solar. I had already given my email ID already in this site, you can see. So it's already the YouTube link has been in the chat box. The earthing concept explained as well, but what about plants installed in dams where the shore is far away from plant? What concept of earthing to be considered in the scenario? If the length to the shore area or the ground area is more, we have to select the cables which already mentioned, that cables and sizing will be moved, and that cable should be moved to the shore area in such a way that it should be placed properly and it should address all earthing faults occurring in the floats. In this panels area also, we are providing all safety protection parts, including lightning arresters also. It also should be properly earthed using the special grade cables. So you can see that every safety component addressed in such a way that the project is secure, safe, and properly used by the operator, and no hazards to operate. Any feedback form to be filled?
So we hope all the questions are answered. Thank you, sir, for reading all the interesting questions and patiently answering it. So,
Is there any questions pending? Is anyone I have to answer? Ajit sir? Ajit sir?
So, sir, I request all the participants, you can just you just put this into the chat box.
Hello,
and we will collect
Is
it.
anybody have questions?
Yeah, we will collect it, sir. We will collect it and let you know.
Hello?
I think I know you are not audible. We will collect it and let you know. If there are questions and all, we will try to. We will email you. We will email you and collect it, and we will circulate among the people. So I hope if you have any more further questions, kindly put it in the chat box so that the student team can collect and consolidate. Thank you.
thank you, sir, for that explanation. So now I invite Dr. Bobby Philip, sir, Secretary, IEEE ES Kerala Chapter, to express the vote of thanks.
Hello?
Thank you.
Is anybody have questions?
I will, Bobby sir. I will just call Laiju sir, and I will just before starting your vote of thanks session, I'll just call Laiju sir and just explain what we decided.
I will
Yeah.
wait
Sir, can wait. Yeah. I will just explain because he's audio. He's not.
I think it's audio.
Audio issue. So I will just call him and tell him that what we have discussed, and we will put consolidated the questions, and we will drop mails to him. Yeah, just I will alert you, sir. I will just call him.
Okay. Yeah.
Hello, sir.
I will call him.
Hello everyone. By that time, you can post your queries in the chat box.
So, sir is there. Sir, you can unmute and tell if
Yeah,
you want.
I just, hello, Bobby sir. I just conveyed our thanks to over phone, but formally, kindly take the floor to express the vote of thanks, sir.
Okay, okay. So, respected Chair, Suher sir, Vice Chair Shobha Madam, Vice Chair Ajgovi sir, and also the coordinator of the program, Ajgovi sir, is coordinating this program. KCB engineers, students, and other participants. Today, we in the third edition, third in this webinar, KCB experts will be, a webinar series conducted by PS Kerala chapter in association with KCB engineers. The third edition was on dam top solar and how KCB has been doing with dam floating projects in dams, and we had a very nice session by Laiju MSR, first experienced person, and has a good expertise in solar PV projects, and it was a very session, and we got a feel as if we were in the actual site. So he was actually going through the various aspects, even the mechanical, the design structural aspects were also being covered by the talk, and had a nice overview, and in some detail we could understand what are the various modules that are there that could be there in such a dam top float solar PVs, and we could understand that there is a good prospect for such projects, and increasingly we'll be seeing such projects by KCB as explained by Laiju Masa. And he cooperated with us patiently initially, because initially we had some technical snacks, and he was adjusting with us and very patiently, and he took the session very informative, and finally he queries in a very patient manner. I thank you, sir, for coming over and joining us to give us a very informative lecture. Thank you, sir. Next person I would like to thank is the chair of PS Kerala chapter. He has been the motivation behind this program, and in fact, I thank him on account of formality. I thank him. Thank you, sir, Suher sir, for attending this session. And next person to thank is our Vice Chair Shobha Madam, and she has introduced. She has given a brief introduction about the program at the beginning, and it was helpful for the participants and attendees. I thank her for also, on account of also for helping us. And the other PES leaders who are also there, who are supporting us, and many are here, were here also. I thank also for cooperating with us. And the attendees, many from KCB, and student communities and researchers were there. I thank all of them and the volunteers who coordinated it nicely, IEEE Kerala Section and other volunteers from PS Kerala. I thank all of them for contributing to a nice organizing and the conduct of the program. And lastly, I missed Ajit sir. He is the instrumental behind this. Is the person behind this program. He is coordinating, and I thank him also for, for the efforts he has taken to organize it well. Thank all of you. Thanking all of you, and with that, I am ending my talk. Good evening, good night to all, and that's all. I think by this the session will be over.
Thank you, Bobby sir. Just quick announcements. We have a session tomorrow. It is about the utility PV power plants and EV initiatives of KCB Limited. The session will be handled by Engineer Joseph VK. He is actually the Chief Engineer of REES, Renewable Energy and Energy Savings Wing, KCB Limited. At the same time, do log in at 7 tomorrow again. And we have 2 more sessions coming actually scheduled. The first session, the second session, the third session will be on rooftop PV plants, Saura program. So it's a initiative from KCB Limited, and ANET also joins into that initiative. It's handled by Engineer Mathulal. He's executive engineer, the project manager of Saura program. On 30th, we have the last session of this webinar series. The last session will be handled by Engineer Hari Kumar KP. He is actually our treasurer of IEEE PS Kerala chapter, and he's assistant executive engineer of transmission subdivision Pala. So do tune to all the sessions, and you will get all these notifications in due time. So please join us and attend all the sessions. Thanks for again participating for this nice session. Thank you, Raju sir, for this. I hope we can end this session.